Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 8, 2025, just 2 days ago. This paper introduces a new optimization method that reduces perception errors in multimodal models by a substantial 30.5%. The paper is titled, Perception-Aware Policy Optimization for Multimodal Reasoning, and it tackles a key bottleneck in how these models actually see the world. The authors show this new approach improves performance on vision-heavy tasks without needing any extra data or external models. So this first figure really highlights the core problem the authors are tackling. They analyzed a common training method called group relative policy optimization and found something striking. A massive 67% of all failures were perception errors. This means the model's logic might be sound. It just isn't correctly seeing what's in the image. Now, with their new method, perception-aware policy optimization, those specific perception errors are cut by over 30%. You can see in the geometry example, the model trained with group relative policy optimization misreads the triangle, while the new one sees it correctly. Building on that, this diagram illustrates exactly how the new method works. The top part shows the existing group relative policy optimization, where the model gets an image and a question and is rewarded for good answers. The key addition is the bottom part, for perception-aware policy optimization. Here, they take the same image and corrupt it by masking out random patches. Then, they penalize the model if its answer doesn't change much. This penalty is called the implicit perception loss, and it forces the model to actually rely on visual details. This table then details the impact of weighting that implicit perception loss. This loss is calculated using something called Kullback-Leibler divergence, which is a way of measuring how much the model's answer changes when the image is corrupted. We see here that as the weight increases up to 0.02, performance gets better, with an overall gain of about 4.4%. But if you push that weight too far, like to 0.04, the model actually collapses and performance plummets. So it's a real Goldilocks situation. You need just the right amount. Alright, so after finding the right weight for that loss, the next logical question is how you should actually corrupt the image to get these results. This table breaks that down, looking at two key factors. First, the masking strategy, meaning, do you mask random patches or do you try to be smart and mask specific, semantic parts of the image? And second, the masking ratio, which is just how much of the image you block out. And what's interesting is that simple random masking at 60% works best, especially on vision-heavy tasks. So with that optimal masking strategy decided, let's look at the main results. This table compares the baseline, group relative policy optimization, against their new method, perception-aware policy optimization, or PAPO. They test this on 3 billion and 7 billion parameter models across two kinds of tasks, general reasoning, and, more importantly, vision-dependent reasoning. The new method wins across the board, but the real story is in that vision-dependent column. Here, the performance jump is massive, nearly 8%, which really confirms that their new loss function is doing its job. Now, while perception-aware policy optimization gives great results, there is a catch. If you turn up the perception loss too high, the model can actually collapse. So, this table explores different regularization techniques to prevent that. Regularization is basically a set of rules to keep the model stable during training. The best solution they found is something called double entropy loss. Entropy in this context is a measure of randomness in the model's answers. By controlling it, they not only prevent collapse, but get the best results yet. A nearly 8% boost on vision-heavy tasks.